In this video, I'm going to talk about solving a system of equations by graphing. So just as a reminder, a system of equations just means two or more equations. It's just two or more equations that you're looking at the same time. A solution to a system of equations is the point or points that satisfy all of the equations in the system. So it's the point or points that satisfy all the equations in the system. When you're graphing, it is the point or points of the intersection. So if you draw the two lines, it's where the lines intersect with each other. That's going to be the solution for the system. As far as number of solutions goes for a system of equations, there are three cases. One case is that you would have one solution. Another case is that you would have no solution. And the last case is that you would have infinite solutions. The graph for one solution would look like this. If I have two equations in my system, I have two lines. So here's one line, and here's another. Doesn't matter how you draw the lines, as long as they're intersecting at only one point. That's an example of what the graph of a system would look like for one solution. The graph for no solution would look like two lines that never intersect. So if this is my first line, a line that would never intersect with that one would have to be parallel to it. There is no point where these two lines are going to intersect. They have the same slope. They're parallel to each other. So that would be no solution because there's no point where they intersect. Infinite solutions, the graph would look like this. If this is my first line, the second line would be on top. It would be the same exact line. If the two lines are the same exact line, there's infinite solutions. For classifying the system of equations, there's two different things we could say about the system. We could say that it's consistent, or we could say that it's inconsistent. Consistent means that the system has at least one solution. At least one solution. Inconsistent then means, you can probably guess, no solution. If I can categorize a system as consistent, I also have to say what kind of consistent it is. I could say it's independent, or I could say it's dependent. Independent means one solution, and dependent means infinite solutions. So just to go over that again. Consistent means at least one solution. Inconsistent means no solution. If I categorize something as consistent, I need to also say if it's independent or dependent. And independent means that there is only one solution. Dependent means there are infinite solutions. So if I wanted to finish filling in this chart up here, I would say that if I had one solution, that would mean that the system was consistent and independent. So the system would be consistent and independent. For no solution, I would just put inconsistent. And I don't have to fill in this box. For infinite solutions, I know it's consistent and dependent. Consistent and dependent. To solve a system of equations graphically, the first step is to graph all the equations on the same graph. So graph all equations on the same graph and make sure you're neat and you include a lot of points for accuracy. The second step is to find the point of intersection. Find the point of intersection if it exists, because sometimes you'll have no solution, and that point of intersection is the solution. Okay, if you want to check a solution, all you have to do is plug the point that you get into both equations. If you plug the point into both equations and it satisfies both of them, then that solution is correct. So it must satisfy both equations. Let's determine if negative 2 comma 3 is a solution for this system below. So if x is negative 2 and y is 3, I can plug those values into the equations that I have and see if the statements are true. So first let's start with x plus y is equal to 1. So I'm plugging in x is negative 2, y is 3, and if I add those together, it should be equal to 1. Well, negative 2 plus 3 is 1, so 1 is equal to 1 is the equation I get, and that is correct. So negative 2 comma 3 works for my first equation. For the second equation, 2x minus y is equal to negative 7. I'm just plugging in these points to check that they work. So I'm just going to rewrite this. And I'm plugging in negative 2 for x and 3 for y. So I get negative 4 minus 3 is equal to negative 7. If I add negative 4 and negative 3, I get negative 7 is equal to negative 7. That works. So yes, this satisfies both equations, this point. So yes, negative 2 comma 3 is a solution to that system. For example 2, the first thing that I want to do is rewrite my equations in slope-intercept form so they're easy to graph, because I want to graph the two equations. So what I'm going to do for this equation here is I'm going to add x on both sides, and I'm going to get y is equal to x plus 1. That means my y-intercept is 1 and my slope is 1, which I can write as 1 over 1, which means I'm going up 1 to the right 1. So my y-intercept is 1, and I'm going up 1 to the right 1, up 1 to the right 1, doing that, I can just, that should be enough. And then I can do it to the left. I would go to the left and down one, to the left one, down one, and so on. Continue that line. All right, for my second equation, I would subtract x on both sides because I want to get that output by itself, and y is my output. I have y is equal to negative x plus 5. That means that my y-intercept is 5, and my slope is negative 1, which I can write as negative 1 over 1. That means down 1 to the right 1. So I'm going to start by graphing my y-intercept, which is 5, and then I'm going down 1 to the right 1, down 1 to the right 1. I don't have to continue anymore. I already found my point of intersection. I draw this line, and my point of intersection is at 2, 3. So that would be my solution. 2, 3 is the solution. For example number 3, I have 3 equations. This is still a system, even though it's not just 2. Even though most examples will have 2 equations, you can always have more than that in a system that you need to solve. So, first thing I'm going to do is I'm going to label these 1, 2, and 3. Equations 1, 2, and 3. Equation 1, I have x plus 4y is equal to 4. The first thing I want to do is change that into slope-intercept form. So I'm going to subtract x on both sides. I'm going to get 4y is equal to negative x plus 4. From there, I need that y by itself for slope-intercept form, so I need to divide by 4 to get that y by itself. If I do that on the left, I have to do that on the right. And I end up with y is equal to negative 1/4 x plus 4 divided by 4 is 1. So this is my new first equation that I'm going to graph. So I know that my y-intercept is 1, and the slope is 1 over 4. I meant to use this. My slope is equal to negative 1 over 4. That means down 1 to the right 4. Alright, so let's graph that. I have 0, 1, down 1 to the right 4, down 1 to the right 4, 1, 2, 3, 4. And I'm just going to connect those. Okay, for equation number 2, I have negative 3x plus 4y is equal to negative 12. First thing I got to do is get this y by itself. So it's in slope-intercept form, so I can graph it easily. So I'm going to add 3x on both sides. I'll get 4y is equal to 3x minus 12. From there, I need this y by itself, so I got to divide by 4 on both sides. And I'm going to get y is equal to 3x divided by 4 is 3 over 4x minus 12 divided by 4 is 3. So this is my equation. That means my y-intercept is negative 3, and my slope is 3/4. So I'm going to plot this. I have negative 3, and my slope is 3/4, so I'm going up 3 to the right 4. I already found my point of intersection. I don't need to continue on anymore. There's my graph. And I need to make sure that point of intersection also satisfies my third equation, which is x is equal to 4. So I'm just going to graph that. X is equal to 4 is all the points where x is equal to 4. It doesn't matter what y is. No matter what I plug in for y, because there is no y, x is equal to 4. So that is going to be the vertical line on 4. X is 4. And that satisfies that point as well. So this point here is the solution. That is 4, 0. So I have 4 comma 0 is the solution to this system.